this video we are going to talk about the detecting conflict serializability using precedence graph technique. Okay, so we'll detect if the schedule is conflict serializable or not by using the precedence graph. This is second way of identifying. The first way of identifying this is swapping the non-conflicting instructions. Okay, that we have discussed already in previous video. Okay, so here we are going to talk about the conflict serializable schedule by using precedence graph. Okay, now what is the rule? We already know what is precedence graph. We will check here. Now the rule is that if the precedence graph does not contain a loop or cycle, then the schedule is conflict serializable. Okay, so we have to draw the precedence graph of the schedule. So consider this schedule as S1 having two transactions T1 and T2. So while drawing precedence graph, we know that the vertices of the graph represent the transactions, that is T1 and T2. There are two transactions, so two vertices. We have to draw a flow from T1 to T2. Now while drawing the flow, we need to check two things. First one is whether there is a presence of write operation, and second one, if that write operation has any combining pair in another transaction on same data item. Okay, so write operation and the sequence we have to check if it is on the same data item and which belongs to different transaction. So here we will see. So first of all, I will tell you that underline all the write instructions. So there are 4 write operations here. Okay, we have underlined. Okay, now we have to see, concentrate on first write operation. So this is on variable a. Okay, and it is belonging to T1. So now check any other operation on T2 is on A, whether it is read or write. Regardless of this, we have to check whether any other operation on T2 on variable A. So yes, this is read operation on variable A in T2 and write operation also on variable A. So the sequence will go like this: write to read. Okay, so first write is made before this read. So this first write A belongs to T1, so the flow is from T1 to T2. So we will draw here T1 to T2. Right, now second flow is from this write A to again this write A. The same, we have drawn the same arrow. Okay, now go to the next write. Next write is this one. So first of all, I will number all the write. This is first write, this is second write. Okay, in second write, if you check, now check any other operation occurring after this on T1 in T1. So in T1 there is no operation on variable A, so no need to concentrate on second write instruction. Now check third write instruction. In third write instruction, it is in T1 on variable B. So check after this third write instruction in T2 any operation is occurring on the same variable B. So yes, in T2 we are having two operations occurring on same variable B, that is read and write. Okay, so this arrow will go this way, like write is occurring before read and again write is occurring before write. So arrow direction is T1 to T2, that already we have drawn in the graph. Okay, now next is fourth write. After fourth write there is no instruction, so we no need to take into account this write operation. So this concludes the graph. So in this graph we found that there is no cycle or no loop. There is no cycle. Okay, no cycle. So the schedule S1 is conflict serializable. Okay, this is conflict serializable. So if precedence graph is not having any cycle, then the schedule is called as conflict serializable. Okay, now here we will see next schedule that is having 3 transactions T1, T2 and T3 having these instructions. Okay, now first of all draw vertex for T1, then for T2 and then for T3. Okay, so check all the write operations. Underline all the write operations. There are 2 write operations. Okay, so no need to care about read operation, take into account write operation. So give the numbers 1 and 2. Okay, now see, this is read operation, so there is no any sequence of write here. So check this second read in T3. Okay, second read in T3, it is occurring on X variable, it is in T3, and this write is on X, but it is in T1. So the read of X in T3 occurs before write on X in T1. So the sequence is from T3 to T1. Okay, so draw the arrow from T3 to T1. Right, now after this write, if there any operation on X in other transaction, yes, it is on T2. So this graph will go like this, flow write of X from T1 to T2. So from T1 to T2, this direction. Okay, then any other operation of X in other transaction is this one, that this write. Okay, so this is on X in T2, so the arrow is from T1 to T2. So we already have. Then again concentrate on this X. This is write X in T2, and see in T3 we are having read X. So again this goes like this, T3 to T2, but already we are having T3 to T2. We need to draw one arrow, T3 to T2. Right. So this completes your. So what you have to check on for all the write, we have to check the previous instructions also and next instructions also for write operation. Okay, so this is the precedence graph. Okay, so in this graph, check if there is a cycle or not. Check if cycle. So there is no cycle, because if you go from here, this ends here. So there is no cycle in precedence graph. There is no cycle. So the schedule is conflict serializable. Okay, so this schedule is conflict serializable. Now we'll see one more example. This one. Okay, so there are 4 transactions. So T1, so in precedence graph, T1, T2, T3 and T4. Okay, now underline all the write operations, write instruction, that is WX, WX, WY. There is no write here. Okay, now check in T3 WX is there. So before that any operation on X variable in other transaction is this one. So write occurring before this, sorry, read occurring before this write. So the sequence is from T2 to T3. So draw the arrow from T2 to T3. Okay, now this also is the sequence on the same. So T3 to T1, because this write of X occurring before this write of X in T1. So T3 to T1. Okay, then on X any other operation, yes, this read X. So this write of X is occurring before this read of X. So T3 to T4 again, T3 to T4. Okay, so done for this write. Now come for the second write. Second write is of X. So before that all we have traced. Now after this any other instruction of on variable X occurring in other transaction, yes, this read of X in T4. So draw the arrow from T1 to T4. So from T1 to T4 you have to draw the arrow. Now check any other operation on X. No. Now go for the next third write on Y. So you have to check any other operation on Y in other transactions. So in T4 we are having this read of Y. So this will go this way. So this flow is T2 to T4. So T2 to T4 we are having one more direction. Okay. Now I guess all the right operations we have traced on all the variables. Right. Now check if there is a presence of cycle in this graph. How will you check? Now if you go from this flow, this ends here, so there is no cycle. From this way if you come here and then go here, this ends here, no cycle. If you start from here, it ends here. If you start from here, also ends here. If you start from here, goes here. Again, if you come here, there is no cycle. So again, there is no cycle. So this is conflict serializable. So schedule is conflict serializable. Okay. So hope you understood this point by drawing precedence graph to detect the conflict serializability. Thank you.